What have Shear projects achieved? The Science for Humanitarian Emergencies and Resilience program supports world-leading research to enhance the quality, availability, and use of risk and forecast information. The research brings together multidisciplinary academic knowledge and practitioner expertise and experience to investigate the factors affecting vulnerability and resilience to natural hazards. It is a 5-year grant funded by the Foreign, Commonwealth and Development Office and the Natural Environmental Research Council. Shear projects have improved forecasting science, have improved data, and have developed new tools. Improving forecasting science. Landslip. Landslip is bringing together physical and social scientific expertise to improve landslide risk assessment and early warning in India. A key issue in forecasting rainfall-induced landslides is that it is difficult due to spatial and temporal uncertainties in rainfall forecasts, especially in mountainous regions. Landslide forecasting has been dependent on nowcasting data that predicts 1 to 2 days ahead, which puts pressure on landslide warning communication and dissemination. Landslip's weather forecasting prototype has the potential to identify local-level heavy rainfall and landslide patterns up to 15 days ahead, which allows expert users enough time to prepare and alert response agencies with a greater lead time. Improved data. Landslide Evo. Landslide Evo is working to develop an existing flood early warning system in Nepal into a multi-hazard early warning system that also supports resilience to landslides. Landslide Evo has looked into citizen science and participatory approaches to co-generate locally relevant, actionable knowledge on disaster risk reduction. One method that has been tested is using citizen science in secondary schools in the Kanali Basin in Nepal to install local rain gauges, which were compared to data from professional rain gauges nearby to evaluate the quality of citizen science collected data. An analysis shows there is a good match between the data, which means the school rain gauges have good potential. New tools. Forecast-based preparedness action, probabilistic forecast information for defensible preparedness decision-making and action, 4PAC. 4PAC is working to improve forecasts for flooding and drought in Kenya so that decision-makers are able to take early action to reduce the impacts of these hazard events.
So we're undertaking this research in Kenya in a number of different places. We're looking at flood sites in Nairobi and also drought in Kitui County. So far it's been very exciting at a number of different levels. We've had scientific developments and we've had new forecast products, forecasts particularly that come earlier in the season. So we have now forecasts that can come in May for the October, November, December season, which is one of the main growing seasons in Kitui. So very exciting. And we also have better forecasts for flood preparedness. So different kinds of forecasts. But then also for the decision makers, we've really been trying to help them understand what the forecasts say. What does the forecast skill mean? What does the probability mean? And how can they use that in their decision making? So we've been looking at specific decision making processes, early warning systems, and where we can bring in these forecasts.
Overall, Shear projects have demonstrated tangible efforts in improving forecasting science by testing new approaches and assessing how well they perform for application purposes. The projects described in this video are examples from a broader set of Shear initiatives that can be explored further on our website.